So in this question we have to calculate the heat produced in the capacitor on closing the switch S. So this is the circuit that we have. Now when the switch is open, then this is the configuration that we will have. Now we know that when capacitor gets fully charged, it offers infinite resistance. So when it offers infinite resistance, in that case, if I remove this capacitor from here, the circuit will become like this way. And you know, in this open circuit, no current will flow. And so what potential difference, because current is not flowing, means this is offering you the infinite resistance and current is 0. So potential drop across this one is 0 and potential drop across this one is 0, because I will be 0 here. Let's say I1 is 0 here and I2 is 0 here. So you can see that the potential developed across this one will be of 20 volt. And potential developed across this one will be also across this one. If I calculate across this one, so this and this, so current is not flowing, so here the potential difference is how much? That is 0 volt. So C1, if I write Q14 microfarad capacitor, then this is going to become 20 times 4, that is 80 microcoulomb. This is the initial when switch is open. This is when switch is open. When switch is closed, if I draw the circuit when switch is closed, so this is when switch is closed. And when switch is closed, if you see, again, if we talk about the charging of the capacitor, then in that scenario, once the capacitor gets fully charged, then I will say that this capacitor will offer 0 resistance, infinite resistance, and so this will be removed and this will be also removed, because it is offering infinite resistance here. Now, so if I calculate the potential difference here again, so here again I1 dash will be 0, and in this I2 dash, if we calculate, then there is no source for this circuit, so I2 dash is also 0 here. So you can see that the potential difference across this remains here as 20 volt, and across this also remains 0 volt only. So I will say that because the charge on the capacitor, this is initial, and Q15 microfarad is how much here? 0. Similarly, finally, if I write Q14 microfarad capacitor is 80 microcoulomb, and Q15 microfarad capacitor is 0 microcoulomb only. So you can see that charge remains same. Charge is not changing before and opening, when the switch is open and after switch is closed. So I will say that the heat dissipated across the capacitor is 0. Heat dissipated across capacitor is 0, because if charge on the capacitor will change, then only heat dissipation will occur.